Why is dimensional accuracy difficult in machining? Imagine trying to carve a sculpture out of ice that melts slightly every few minutes. That's similar to what machinists face when trying to hit exact sizes and shapes. Achieving perfect dimensional accuracy in machining is a real challenge because many factors are constantly at play. First, the machine tools themselves can cause issues. Large computer numerical control machines, which are common in manufacturing, can bend or flex under cutting forces. This bending makes the tool move slightly off course, leading to errors in size. When the machine heats up during cutting, parts of it expand. This thermal expansion can change the dimensions of both the machine and the workpiece, making it even harder to stay within tight tolerances. The stiffness of the machine and how well it's built influence how much it deforms when cutting forces are applied. Next, the material being machined also plays a big role. Softer or less rigid materials tend to deform more easily when cut. Thick pieces are especially tricky because they tend to bend or warp under the cutting forces. Residual stresses inside the material can cause warping after machining, changing the final dimensions. Harder materials wear out tools faster, which can lead to inconsistent cuts and size variations over time. Cutting parameters like speed, feed rate, and depth of cut also matter. If these are not optimized, they can increase forces and heat, causing more deformation. Finding the right balance requires testing and sometimes complex calculations to predict how the system will behave. Measuring the finished parts adds another layer of difficulty. Manual tools like calipers can introduce human errors. Even advanced coordinate measuring machines, which are very precise, can be affected by surface roughness or tiny imperfections on the part. Ensuring the measurements are accurate is essential but can be tricky. In manufacturing, achieving the right size involves choosing the best equipment, like high-precision CNC machines, and using stable fixtures to hold parts securely. Controlling the environment to reduce temperature changes and using real-time monitoring systems helps keep things on track. Adjusting cutting parameters based on the material and part design is also key. In the end, maintaining exact dimensions in machining is a balancing act. It requires controlling machine behavior, managing material properties, fine-tuning cutting conditions, and measuring carefully. All these factors interact dynamically, making it tough to produce parts that meet very strict size requirements every time. That's why precision machining is both an art and a science, especially in industries like aerospace, automotive, and medical device manufacturing, where even tiny deviations can have big consequences.